Right, so here we have the graph. I'd like you to check number 4. Hopefully you have some of these points graphed as well. I've brought over the two variables that we're looking at here because we're looking at length versus area. And so length is on the x-axis and area is on the y-axis. And so I've just brought over length and area from our table on the front side. And the question is, what is the greatest area on our graph? Well, we know the greatest area happens right here, and that was on our table as well. Matches up with 36 square feet was our greatest area. And what was the length that was paired with that area? On the front side, we talked about a length and a width. Here we just have a length versus area. So the length that is paired with that is 6 feet. So 6 feet was the length that gave greatest area. What would the width be for that area? We talked about that on the front side as well. 6 feet was also the width, because 6 by 6 got us the 36 square feet for that area. Okay. Draw the shape of this garden, label the length and the width. We talked about this on the front side, that really what we have here is a special type of rectangle called a square. And that's probably not the best square ever drawn, but I'm not an artist, I'm just doing the best I can. So we've got 6 feet by 6 feet. That gave us a total of 36 square feet of area. Now let's think back to earlier this year when we were talking about transformations to see if we can maybe write the equation for this graph. So we know this shape is a parabola. So we know the parent function is y equals x squared. Remember, a parent function is the most original version, the most basic version of that type of graph. So if you look at the graph of y equals x squared, we know that it looks like this. It's centered right. Ooh, let's try to make that sketch a little bit better here. It's centered right at the point 0, 0. It's centered on the y-axis. The one that we have doesn't look quite like that. It looks similar to it, but it is more like this right here. So let's see if we can figure out what's happened. So it's been reflected upside down. So I might just say reflected. I'm going to cross out the words over the and just put reflected upside down. Well, I can add to that. Upside down over the x-axis. Since it's been reflected upside down, that means that it's been reflected over the x-axis. It's been translated to the right. Let's think about how far to the right did that translate up here. So think back to our original parent function has a vertex here of 0, 0. And this has been translated to the right 6 units. And then it's been translated up 36 units. So up 36 and right 6 to get where it's at. So it's been flipped upside down. It's been translated right 6 and up 36. That's where the new vertex is here. So let's write that in. So right 6 units and translation up 36 units. So let's see if we can think about how that works. Remember, for a reflection upside down, that means that we put a negative with the y. Okay, so whenever you reflect upside down, we have something happening along the y-axis, so we put a negative with the y. And then we translated right 6 and up 36. Do you recall, if we translate up 36 units, that's also something to do with the y-axis. Anything on the y-axis has something to do with moving it up or down. Up 36. Now remember, the rule said that we actually do the opposite kind of what we think. So translating up 36 actually means that we're going to subtract 36 from the y. I'm actually going to put parentheses around here to make sure the order of operations is done correctly to get that graph. So the negative sign flips it upside down. The minus 36 translates it up 36 units. And if we added it over to the other side, you'd see a plus 36. But when we talked about it a number of units ago, we did all our transformations with the variable that it goes with. And then we had something happening here where it went right 6. So again, the opposite rule is that you actually will subtract 6 from the x to make it go right 6. And don't forget the little squared symbol. All right, so that should be our equation. We've got the right 6, we've got up 36, and we've got it flipped upside down. I'm going to skip the solving for y part of it for now. Well, if you solve for y, just real quickly, you divide both sides by a negative, and then you add the 36 over here. We didn't really focus on that back in the previous units, but to undo, think of this kind of as a negative 1 here. So you'll undo by dividing both sides by negative 1, and then you'll add the 36 over to the other side. So what you end up with is something like this. The negative kind of transfers over to the other side, and then you'd add 36 over to the other side. So if we were solving for y, we wanted to put it into y equals form, we'd have this equation.